So I got the Arduino here in a pretty decent room that I would get a nice reading. So if I go ahead and first plug in the Arduino and then run the code from processing, show up and map the room from side to side, so as you can see both of them moving together. And so as you can see, that line right there is just this wall going across, and then it reaches a point right there, and that's that corner over there. And then over here it reaches a point like that, where it reads kind of diagonally in that area over here, where there's kind of a separate hallway. That's why it's slanted a little bit right there. And sometimes it makes errors because the sensors aren't perfect, and it corrects it every time it goes back though. And then you can see a little spot right there. That's just from the open door over there. And then you can see it does that just because I was standing in front of it. So if I go ahead and put my hand out over there, as it moves across, it comes down. That's my hand where it's reading right there. And then it comes back and corrects that. This sensor can read up to 500 meters, so think of how big of a room that this thing could map out, or it would take hours upon hours to do it just by drawing it, or even by using some sort of software where you have to walk around the whole room. And then this could just do it in a few seconds just by rotating around. This could be used in many applications. Building inspection, or just anything that involves finding the distance or shape of a room, or even an environment where it's dark or light, doesn't matter at all. The only constraint there is the problem of maybe windows where the light could shine through it and get an incorrect reading. But other than that, it works all the time. Because it generates its own light, it doesn't need an external light source to get it the distance. It uses a servo and a SparkFun LIDAR sensor. So if we look in the insides, we just have an Arduino Uno, which communicates to both the sensor and the servo. And what it does is it rotates this LIDAR sensor around in 180 degrees to map out a room or any environment. Okay, so this is the Fritzing diagram of the LIDAR with the servo, and does the mapping. So you got your servo, your 5 volts input, and your ground, and the signal wire that just tells it to go to a certain degree using PWM. And servos have a potentiometer in them, which can measure its degree that the servo arm is. And then we got the LIDAR sensor. This LIDAR sensor was from SparkFun. There's a SparkFun Fritzing file that I can just download and insert into Fritzing, so that's how I got this. And that has a 5 volt input, ground, the Arduino. And this is the fun part, we got SDA and SCL. So what this is the communication between the LIDAR sensor and the Arduino. And both the Arduino and LIDAR sensor have these things called UARTs, and that stands for Universal Asynchronous Receiver Transmitter, which just allows these two devices to communicate between each other using this binary protocol called I2C. And it's just a binary protocol, just ones and zeros, which transmits and receives to the Arduino and the LIDAR sensor. So the Arduino would transmit to the LIDAR sensor, and then the LIDAR sensor would receive the refresh rate of the LIDAR, how it shoots the lasers out and picks it up, and that's what you can change using the Arduino. And then obviously the LIDAR sensor transmits the binary data, that the distance that the LIDAR picks up, and then the Arduino receives that data, and that's how the UART ports or SDA and SCL ports mean, because the Arduino has designated pins for that, right here, this pin and this pin. So this is my Arduino code. We got the servo library and the LIDAR library made by SparkFun. The servo library is made by Arduino. Then this is just the variable for LIDAR. It's just saying like the LIDAR, this giving the LIDAR library to a variable called LIDAR Light. And then obviously it's stating that I have a servo named my servo. And then this is the servo val is the value of the servo. Servo state is whether the servo is panning left or right. X and Y right here I'm not using in this revision of this program, of this code, just because I'm using a different IDE program to change the X value and Y value to the right points for a regular Cartesian plane, so to where it maps out the lines for the map that the LIDAR picks up. This would be the converted value from the raw value coming from, so raw X, that would just be the angle of the servo, and raw Y would just be the distance that the LIDAR picks up. And obviously you can't plot that on a regular Cartesian plane because it's translations instead of like angle and rotations that the servo is picking up. And then if we jump down to the setup, obviously this is just starting the communication between the LIDAR and the computer, and that becomes important later on. And LIDAR begin, that's just starting up the LIDAR. It sets it, this is 0 means is like the mode, as I said, like it sets it to the timing that the LIDAR picks up, which is 400 kilohertz, which is a lot for a LIDAR sensor. And then this is LIDAR configure 3, that's just the mode that the LIDAR sensor is picking up. So it's just for mode 3 is for the best distance and accuracy. And then if we go down, my servo attached 12, that's the servo signal wire is attached to digital pin 12. So this is what I do initially. Servo val equals 0, servo state equals 0. And I believe servo state equals 0 means you initially want the servo to pan left, and that's why the servo starts off all the way to the right so that it can pan left. If we jump down to the loop, we can see this if loop. So if servo state equals 1, which means if it's turning one direction, you want it to go to this, which is if servo is greater than or equal to 180 degrees, which means it's all the way over as far as possible to either way depending on servo state. You want to make servo state equal 0, which means it starts going the opposite direction. And then otherwise, if servo value is not more than or equal to 0, you just add 1 degree so it keeps on moving the way it is. And then this is just the same thing but in the opposite direction. And then down here after the loops, it tells the servo to move servo val, which was determined up here depending on where it was. So raw X and raw Y would be a polar plot, and a polar plot is just the angle of incidence from 0 to 360 degrees, and that's the X value, and then the Y value is just the distance from the origin. So that's another way to make a plot. other than a Cartesian plane. But right here in this commented out section is the conversion from a polar plot to a normal Cartesian plane, or a regular coordinate plane. And then but it's not, I'm commenting it out here because I do this in my other software which runs the mapping, which is, it's called processing, similar to Arduino. And yeah, I'll talk more about that later. And then down here we just got my printouts, the X value and Y value printouts separated by a comma, and then in each coordinate is just separated by a slash, and that's comes more important in the second part. And then just a delay of 5 milliseconds for stability. So if I plug in the Arduino with the sensor and servo, I can open up the serial monitor and I get the values being printed. So if I just stop the auto scroll, you can see we got the first one is the angle, that's 113 degrees, and then 48 is the distance in centimeters, but it's seeing at that angle is apparently 48 centimeters from the sensor. And as I move up a bit, you get it goes up all the way until it hits 180 degrees. So you can see 78, 79, and 180 degrees, and then jumps back time from 180 to 179 until it hits 0, then it jumps back up, and so on. So this programming is called processing. This was actually made even before Arduino, and Arduino took its layout, and you can see that it kind of looks similar to the Arduino IDE. This uses Java. This is Java here, similar to C++, but a little bit different in some aspects. And this takes that data and arranges it so that it creates an XY Cartesian plane, and it plots the points and creates lines between the points to make the shape of what the sensor sees. So if we start up at the top, we got the import processing. That's just importing basically a library that allows the Arduino in this IDE to communicate, and that's kind of already implemented in the Arduino IDE, because this just isn't for Arduino, this is also for like mainly graphic displays and programming your own graphics. And then if we go down, we got string. A string isn't really like an integer, it's more of a group of words rather than a group of number, or a number that an integer is on, that I usually use on an Arduino. And then that we got each one of those for X and Y. That will be more familiar later when I talk about how I'm using this. And then we got floats, which you're familiar with, and we got the raw X value, which is exactly the same thing as the values in the Arduino IDE, raw X and raw Y. And then we got float X and float Y, and this is just the string converted into a float, not much different. And then float prev X prev Y, this stands for previous, and this is just the last reading of X and Y. This is just the last reading of this, so you can have both readings, so that's how it creates the line in the image. And then string, this is just for the values that are coming in from the Arduino serial monitor that the processing picks up. And then integer, which is the index, and that's just used for splitting the strings into separate X and Y values. And then we got a bunch of arrays here for the lines. This will make a lot more sense later, but this is what creates all the different values for the 180 degrees, 181, because as it transitions it needs that extra extra point to create another line. And you can see here x1, y1, that's the x and y coordinates for the first point of line, and x2 and x2 and y2, that's the second part, the second point of the line segment, so it connects the two of them. And then serial my port, that's just setting up the serial port of the Arduino. If we jump into the setup size, this is just the size of the graphic display that comes up. It just works out for the map that's coming from the Arduino that it's reading from the sensor. Then the frame rate, 30 frames per second, that's kind of obvious. It just the refresh rate of how the graphic display is. And then this is where the fun starts, my port. This is where the Arduino is COM15. You might be familiar with that from the Arduino IDE. And at 9600 baud, that's the refresh rate. It's just how Java works and processing works when grabbing the data from the serial port. And then this is just the buffer, so it reads the data in increments, and this is why I use a slash between the coordinates. It separates them as individual readings. And then we got a void serial event. This just reads the ports, and this the same thing here. It reads it into the slash and creates strings using that. And again, a string is just a group of words. And then if we go down here, this just makes the coordinate reading. It's just a substring. It creates the two strings for it just creates the strings for the individual readings. And then this is where it splits up the x and y coordinates using the comma here, and that's where the indexing comes in handy. And then x, that's the string, and this is where it splits up the substring between x and y coordinates. This is the same thing, but just after the comma. That's index plus 1. Yeah. And then, of course, right here is where it converts the string here into a float and sets that equal to the raw x and raw value, the raw y value. And that it's kind of a pain, but this is what we had at the end of the Arduino, but we can't just send those values through the IDEs. It has to go to the serial port on the Arduino, and then this picks up that serial data on here. Yeah, and that's basically what this whole area is doing right here. So now that we have the float values of x and y, we can draw it. And then if we go down to the draw function, the void draw, this is just a scaling value. I'll talk more about this later. It just scales it so that if the sensor is in a big room, it doesn't go off the screen. You can scale it down so it fits in the area on the screen. And then we got each of those for the x and y axes. And then this is the conversion from a polar plot to a Cartesian plane. So to convert x into regular form, Cartesian form, doesn't really matter, same thing. You take the raw y value, multiply it by the cosine of x times the radian of 180 degrees, which is just pi divided by 180. That gives the radian, because this doesn't take degrees, this takes radian, which is kind of annoying because I have to do this every time. And then for the x, to convert the raw y value, you take the raw y value, multiply it by the sine of raw x times the radian of 180 degrees. Same thing, except instead of the cosine, it's the sine. Yeah. And then this is what just scales the value. It takes the x value, multiplies it by the scale, and add 650, so it centers it. And this is just the same thing. And I multiply it by -1 because the way the processing graphic screen works is that in the graphic screen, the y-axis goes downward. So as you go down on the y-axis, it starts off at the top, and as you go down, the y values increase. So that makes it kind of annoying. So right here I add 800 because that's how it kind of centers the origin of the sensor. So background, this is just the color. So these values stand for the RGB colors. So the first one is red, that's set to 0. The second one is G, green, and that's set to 0. And the last one is blue, 250, which is the maximum, so the background is going to be blue. And then this just prints the X value down here. This is kind of like the output serial. This is similar to the serial monitor of the Arduino ID, except it's down here, and then that just spaces them out, as you can see, and then it prints the Y value and then creates a new line. And then stroke weight is the width of the line that the map creates, just so you can see it nicely. So here, this is just a for loop. It creates an integer 0, and then it goes from 0 to 180 to create a line for each point plotted. And then this is just if I, which is the line, is equal to the raw X value. I'm going back to that just because it creates a line for each degrees, not for each coordinate. Creates the line, so line x1 of I, which is like any number of the certain degree, is equal to previous x, which is the x before the x that we just read now. So it creates a line from the previous x and y coordinates to the new x and y coordinates. That's all this is just doing, and that's just setting them to those values, and this is actually just creating the line. So this is the x, the first x value, second x, that's the first y value, second x value, and second y value. Then if we go down here, this just sets the previous x value to x and sets previous y value to y. So the next time it goes through this loop, those values will be there. And that's it for the coding aspect of this project.